Hello. Today we're going to do something special. We are going to go through common pitfalls when setting up a Siemens S120 drive. So the first thing we're going to do is pick a PLC. And in this case, I'm going to pick a 1515. The reason for this is it has two Ethernet interfaces. And we'll go into why that's important in a moment. Okay, we can pretty much ignore all the device configuration because I don't care. Now we're going to add an S120 into our project. Here's our CU320-2PN. Okay, so what's our first common pitfall? Well, it's the line module. Let's go take my smart line module. I think that's, for me, the most common, but there's plenty of active line modules as well. Okay, populate that into our project. And the first thing I'm going to do is define what version it is. And oh, look, I bought the 5 kilowatt smart line module. Why isn't it in this list? Well, it's not in this list because the 5 kilowatt one doesn't have a drive click interface. If you have a 5 kilowatt smart line module, well then, you can just go ahead and delete it. We don't really care. You are going to do some defining of the interconnections of when the smart line module is ready by way of just blindly assuming that it is ready, which is a bad idea because if you enable the motor modules before the smart line module has had a chance, or any of the line modules has had a chance to fully come up to DC power, you could blow the pre-charge circuit or other bad stuff. Don't do it if you have a real machine. I use that scenario on my demo unit all the time because I'm kind of controlling what I'm doing pretty strictly. However, in a real machine, you don't want to take that chance and blow something up, right? So always use the interconnection and define it properly. If you look in either the hardware installation manual or the commissioning manual, it kind of walks you through some of that. We'll talk about manuals in a different video, but there's pitfall number 1. Okay. Next, I'm going to add in, you know what? Here's what we'll do. We'll add in that smart line module still. Put in a double motor module. And we'll see what happens. Okay, you'll notice that the control unit topology went straight from CU to smart line module to dual motor module. Okay. If I later define this as a vector, this is not an ideal topology for that. When you're using vector drives in vector algorithm, right? And keep in mind, you can use the vector algorithm on both a servo motor or an induction motor. It's just the algorithm that it utilizes. The correct way to do this would be to delete these, drag, drop like this, drag and drop like that. Okay. The reason being that the smart line module doesn't quite support the bandwidth required in the drive click chain in order to accommodate just the higher bandwidth that vector algorithm uses. So, and again, it's either in the hardware installation manual or the commissioning manual or what have you. Sorry, there are so many manuals with Siemens. The plus side is the information is always there. You could just spend a couple days looking for it. That's why I'm here. Don't hesitate to reach out to me if you're one of my customers. If you're not one of my customers, then Well, good luck. No, you can always call the Siemens hotline. The number for that is 800-333-7421, or you can go to the Siemens support website and submit a case there. All right, but moving on. The next common pitfall is quite a bit later. I'm going to do like I have in a couple previous videos. I'm going to spell out exactly which drive click motor I'm using, even though again I could use this drive click motor option up here. Okay, so let's go define all our hardware. Use this 16 kilowatt because that's the smallest one I can. In the motor module, I'm going to go pick the 3 amp motor details. You can see I tend to start with the 1FK7 right? We do have smaller 1FK7 motors, the 022 and the 011 or 015 as well. But due to some size restrictions, the 1FK7 011 and 022 never got updated to the second generation of motors. Now, they're still available, those 1FK7 022s, as the first generation, but there's a handful of features missing from that. So I usually default to the 032. Obviously, it's quite a bit bigger, but due to some of the manufacturing changes they've made for the second gen 1FK7 motors, it's a superior product, and it usually costs less, even though you've got a much larger motor. Obviously, you can't always put a 1FK7 032 into the spot of an 022 design-wise, but I always try to start with that. No, not that one. And if that ends up being too big for my design, then go down to one of the smaller ones. We, of course, do have the S210s with their 1FK2 motors. And I started off quite a bit before those were available. So I, just have this sort of muscle memory of the 1FK7 motors, as it were. They're my go-to. But the 1FK2 motors are fantastic motors, and they have pretty much all the features that you need from a typical servo motor applications. The 1FK7s are a little more capable, slightly higher power densities, higher resolutions, those sort of things. And obviously, the S210 servo drives are what they are. You can get a lot more functionality out of the S120 drive, but you don't always need that. Okay, so we've got everything defined. Great. Let's go and define our what am I doing? Device configuration. We're going to define our telegram of our drives. Okay, so let's say, I'm going to use technology objects. I go to telegram 105 for a technology object. Oh, actually, this is another pitfall. All right, if I'm not using technology objects, let's say I want to use position control completely in the drive and use something like Synapause or the basic positioner technology object to control this drive. Well, that would mean I use Telegram 111. You can see it's not in this list. What I have to do first is go into the parameterization of the drive and enable basic positioner function module before Telegram 111 will be accessible. Okay. But in our case, I'm trying to show off something else. We've got Telegram 105 on both of these. Oh, there we go. All right. And now, I can't remember if it's because of the order I did things or not, but I did the Telegram first, right? And then I'm going to go in and define my connection to my PLC. Okay. Right, as always, I can drag and drop. Let's see, I hover on this one. What is this? This is my Ethernet, my X127 commissioning interface, right? And the top one, hover over that, and I should say, it didn't really tell me either. Profinet interface, yeah, that's my Profinet X150, bottom one, is my X127 commissioning interface. Let's see if it'll even let us drag and drop this onto the PLC. Yep, it will. Okay. Keep in mind, if I make this connection to X127, it doesn't support IRT. I don't even think it supports most Profinet functions. It's designed for plugging your PC directly into that port, or plugging it into a switch, which then lets you program the drive without mucking up the Profinet traffic or anything like that. Right? So that's bad. We don't want to do that. Okay. One of the plus sides of this left click on that not assigned is if I do that, it automatically knows, yeah, you want to use the Profinet connection, the X150. But I could make the wrong connection here too by choosing, excuse me, Profinet interface 2. Yes, let's modify. What that was just automatically changing the subnet of the drive to match that of P2, or port 2 of the PLC. This port does have Profinet, however, it does not support IRT communications, which is required for Telegram 105. So that's another common pitfall. Okay. Now, this port, like I said, does support Profinet, although in a limited fashion. Typically, will support fewer nodes than the main P1 interface. Okay, let's go ahead and delete that connection. Delete that connection. There we go. So we're going to choose Profinet interface 1. Yes, modify. So they're on the same subnet. Okay, great. Everything's talking. Okay, one might assume, okay, that's enough. We're talking. Okay, and let's just go ahead and compile the PLC. So everything's good and happy. Oh no, what is all this? Well, fortunately, some of these alarms are pretty good. Isochronous mode is enabled, blah, blah, blah. Let's see, modules need to be in isochronous mode. Actually, yeah, I don't even see a message saying that the thing that is wrong that I'm thinking of. T performance. Yeah. So the other thing we need to do to utilize Profinet IRT is to define our topology. Okay, so I think I talked. This is a pretty common step to skip because we're not used to having to define it. We only need to find topology for a handful of cases. Utilizing IRT is one of them. And so in this case, I need to go from the exact port I'm going to use, right? So before in network view, I had to choose the right interface, X1 or X2. In this case, I need to choose not only X1 or X2, but which port am I using, P1 or X1, P2. So I usually put my connections to P2 out to the broader network and daisy chain, X150, P1, and then P2 of this one to another, down the chain. In this case, we only have one node, so no big deal. Okay, let's go ahead. All right, that's got to be it. Everything's good now. Go ahead and compile. Oh no, everything's still screwed up. And the reason for that is, if we expand this message, it says modules operating in isochronous need to be assigned to an isochronous cycle organization block. Well, since we're planning on utilizing technology objects, in that case, it would be MC servo OB, which hasn't been defined yet because we haven't added in a technology object. So you may get stuck in this land of, oh, where's this fault? And you click on the link and there's nothing there. You could be chasing your tail for quite a while before you realize that all you need to do is keep moving forward in order to get rid of these. Right? So in this case, we'll just go add in a positioning technology object. And you see when we do that, that automatically adds in MC servo, and that's going to be our sync domain block. So let's make the connection here. Technology object 1 will be drive axis 1. Add in another. Define this connection to the next axis. There we go. Okay. Now, click on the PLC. Click compile. Okay, so we still have something not happy. Let's see what this says. Let's click on that link. And because we messed around with our PLC connections so many times in our network and then added topology, yada yada, it should typically set up the sync domain for you. But if you got stuck in some of that no man's land before, this may not have happened correctly. So now we got to go in and ensure that in the properties of our PLC, under advanced options, real-time settings, we select IRT. That sets this up as the PLC as the sync domain master, sets up a sync domain, yada yada. And I don't recall if there's anything else we need to do. Isochronous mode is enabled. And you can see that these two drive axes telegrams are set up for isochronous mode as well. So that might be it. Let's give it one more go. Hey, there we are. Okay, so I think that's the majority of some of the issues that I've encountered and seen other people encounter in the past in terms of at least getting a drive set up for technology objects. There are by no means just those. But I thought a video like this would be very helpful because I find this sort of help to be pretty commonplace. So I wanted to have a handful of videos where I go through and set things up and run into those same problems that a lot of people do. A lot of times in these videos you say, oh, you do just drop this in, do things in the perfect order and everything's fine. And in the real world, right, it never happens that smoothly. So I wanted to make a video where it obviously doesn't happen smoothly and we can work through some of those issues. If there is something else you would like to see, please leave a comment and I will try and do that. Alrighty, I'll see you folks next video.